Hello, grade 12. Today we're doing lesson 8.1, so now we're finished chapter 7, moving on to chapter 8. And 8.1 is called Sums and Differences of Functions. So we're going to start with a few definitions. So first we have the superposition principle. Superposition principle. And this states that the sum of two or more functions can be found by adding the y-coordinates of the functions at each x-coordinate. So, this is how we can graphically solve for the sums and differences of functions. And this can also be done algebraically. So now we're going to do this both algebraically and graphically, and then we'll do a word problem, and then I'll give you your homework questions. So first, algebraically. Number 1. So if we have two functions, f of x and g of x, and f of x equals negative 2x plus 5, and g of x equals negative x plus 9, then first of all, A, we need to find when y equals f of x plus g of x. So we're going to add these two functions together to get a new function. So basically all we're going to do is we're going to take this function f of x, negative 2x plus 5, and we're going to add it to g of x, which is negative x plus 9. So this equals negative 2x plus 5 plus negative x plus 9. And now we're just going to combine like terms and simplify until it's as simple as it can be. So negative 2x minus x is negative 3x, and 5 plus 9 is 14. So I have negative 3x plus 14. I can't simplify this any further, so this is now our new function. We have now added f of x and g of x. Letter B, we're going to subtract them. So y equals f of x minus g of x. So f of x is negative 2x plus 5 minus, and make sure you put the second one in brackets because we're subtracting the entire function, negative x plus 9. Now I'm going to rewrite this without the brackets, making sure that I subtract each term in this bracket. So negative 2x plus 5 plus x, because minus minus, and then minus 9. Now I'll combine like terms. So negative 2x plus x leaves me with negative 1x, and then 5 minus 9 is negative 4. Letter C, we're going to flip them around and do y equals g of x minus f of x now. So now I have negative x plus 9 minus negative 2x plus 5. I'm going to eliminate the brackets. So negative x plus 9 plus 2x minus 5. Negative x plus 2x is 1x. and 9 minus 5 is 4. So x plus 4. All right, number 2, I'm going to give you two new functions. F of x equals negative 3x squared plus 4, and g of x equals 3x minus 7. So now I have an x squared in there and an x, so I'm going to end up with a quadratic in the end. So letter A, we will add f of x and g of x. So f of x is negative 3x squared plus 4 plus g of x, which is 3x minus 7. So negative 3x squared plus 3x, I can't combine those because they're not like terms, and then 4 minus 7 is negative 3. So I could leave it like this, or I could take out a negative 3 from each term. That would leave me with x squared minus x plus 1. And those are both correct. Letter B, y equals f of x minus g of x. So negative 3x squared plus 4 minus 3x minus 7. First, I'm going to rewrite it without the brackets. So negative 3x squared plus 4 minus 3x plus 7 equals negative 3x squared minus 3x, and then 4 plus 7 is 11. And then letter C, we're going to do g of x minus f of x. Y equals g of x minus f of x. So 3x minus 7 minus negative 3x squared plus 4. I'll rewrite it without the brackets first. 3x minus 7 plus 3x squared minus 4. I'm going to write the 3x squared first because that's what we do. We write the highest degree first. So 3x squared plus 3x, and then negative 7 minus 4 is negative 11. And that's subtracted. So that's how you do it. You add and subtract functions algebraically, and now we'll do it graphically. So if I have these two functions, f of x equals x plus 3, and g of x equals negative 3x minus 3, and I want to find what f of x plus g of x is. So I'm going to make a table of values. I'm going to pick some x values. Then I'm going to figure out what f of x is at those x values. Then I'm going to find what g of x is at those x values. And then I'll be able to find what the two added together will be. So if I pick negative 2, negative 1, 0, 1, and 2, just to give me a range of positive and negative numbers, and I plug these x values into the function f of x up here. So negative 2 plus 3 would be 1. Negative 1 plus 3 would be 2. 0 plus 3 is 3. 1 plus 3 is 4. And 2 plus 3 is 5. Now plugging these values into g of x. So negative 3 times negative 2 is positive 6. Minus 3 is 3. 0, negative 3, negative 6, and negative 9. Now, for f of x plus g of x, if you go back to the definition that we wrote at the beginning, it says that the sum of two or more functions can be found by adding the y coordinates. So these two columns would be the y coordinates of the functions at each x coordinate. So we keep the x coordinate and we add, in this case, we add the y coordinates. So we're just going to take these two columns and add them together to give us the y coordinate of f of x plus g of x. So 1 plus 3 equals 4. 2 plus 0 equals 2. 3 plus negative 3 equals 0. 4 plus negative 6 equals negative 2. 5 plus negative 9 equals negative 4. So now the new coordinates of the added functions are -2, 4, -1, 2, and so on, 0, 0, 1, -2, and 2, -4. So now we're going to graph all three of these lines on the same graph. So on my graph, I'm going to go up to at least 6 and down to at least -10 on the y-axis, and then from -2 to +2 on the x-axis. So if I go up every other, so 1, 2, 3, this is x, -1, -2, -3, this is y. I'm going to go up by 2's on the y-axis, 2, 4, 6, 8, 10, 12, -4, -8, -12. Okay, and then I'm going to take the first function f of x and plot those points. So -2, 1. -1, 2. 0, 3. 1, 4. And 2, 5. And then I'll connect those with a line. And label that f of x. Then I'll do g of x, plot those points, so -2, 3, -1, 0, 0, -3, 1, -6, and 2, -9. And then I'll connect those with a line. And label that g of x. And then last, I'll do the combined function f of x plus g of x. So my coordinates are -2, 4, -1, 2, 0, 0, 1, -2, and 2, -4. And I'll label that one f of x plus g of x. And that is how we solve one of these graphically. Okay, we'll do another one this way. So number 2, f of x equals x squared. G of x equals x minus 4, and we want to find f of x plus g of x. So I'm going to make the table of values again and then graph these. So this one's just a little bit different because we have one quadratic and one linear. So it's going to look a little bit different. Here goes my table of values. So I'll start with my x values that I'm going to choose. I'm going to choose the same range. -2, -1, 0, 1, and 2. Then f of x, g of x, and f of x plus g of x. So f of x, I just need to plug in -2, so -2 squared is 4, 1, 0, 1, 4. G of x, -2 minus 4 is -6, -5, -4, -3, -2. And then f of x plus g of x, I'll just add those two columns together. So 4 minus 6 is -2, 1 minus 5 is -4, 0 minus 4 is -4, 1 minus 3 is -2, and 4 minus 2 is -2. Sorry, +2. All right, now I'm going to draw my graph. So I'm going to go up to 4 on the y-axis and down to -6, and then from -2 to +2 on the y-axis. Sorry, x. Okay, I'll start by graphing f of x equals x squared. So my points are negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So as you can see, this is a quadratic. And I'll label that f of x. Then I'll draw g of x, so negative 2 is at negative 6, negative 1 is negative 5, 0 is at negative 4, 1 is at negative 3, and 2 is at negative 2. And I'll connect those with a line. And then I'll graph the combined functions. So negative 2, negative 2, negative 1, negative 5, 0, 0, sorry, not 0, 0, 0, negative 4, 1, negative 2, and 2, 2. So again, this is forming a quadratic. I think I missed one, maybe. This one's also at negative 4, not negative 5. Okay, and that is our combined function f of x plus g of x. Okay, now we're going to do a word problem. So this question is found on page 425, and it's number 10. So the question says, a hot dog vendor has fixed costs of $120 per day to operate, plus a variable cost of $1 per hot dog sold. He earns $2.50 per hot dog sold in revenue. The maximum number of hot dogs that he can sell in a day is 250. So part A says, write an equation to represent, first of all, the total cost, and secondly, the revenue. So part A, part 1, we'll start with the cost. So the cost as a function of the number of hot dogs sold, so C of H, equals $1 per hot dog sold plus a fixed cost of $120 to operate. The revenue for the second part, how much does he make? The question said he earns $2.50 per hot dog sold in revenue. So R of H equals 250 H. Okay, part B says graph these on the same set of axes. We're going to skip that and move on to part C. Identify the break-even point and explain what its coordinates mean. So the break-even point will happen when the revenue and cost are the same. So when revenue minus cost equals 0. So we're going to do that, revenue minus cost. So considering what we just learned in this lesson, we're going to subtract these two functions. So R of H minus C of H. So that would be 2.5 H minus H plus 120. And that has to equal 0 because the revenue and minus the cost has to equal 0 because it's the break-even point. So combining those two, we have 250H minus H would be 150H plus 120 equals 0. Actually, it will be minus 120 because this minus sign needs to go into the bracket. Now we'll add 120 to both sides so that we can work towards isolating H. So now we have 1.5H equals 120. And we'll divide both sides by 1.5. So H equals 80. So the revenue minus cost equals 0, and that happens when 80 hot dogs are sold. So how much money would he be making then? So revenue of 80, R of 80 equals 250 times 80, and that is 200. So this coordinate is at 80 hot dogs and $200. Right, letter D. Develop an algebraic and a graphical model for the profit function P of H equals R of H minus C of H. So profit is revenue minus cost. So R of H was 250H minus C of H was H plus 120. 250H minus H minus 120 equals 150H minus 120, and that is our simplified function for profit. So that's an algebraic model. We're just going to skip the graphical model for now. And then we need to look at E, identify the domain and range in the context of this problem for cost, revenue, and profit. So just make a little chart here. Cost, revenue, and profit. Domain and range. So the cost is going to go from $0 up to $250 because that's how many hot dogs he'll be selling. So this is domain, so it's the X value, which is H in this case, so number of hot dogs. So on the X-axis, we can have from 0 hot dogs up to 250 because it says in the question he can sell a maximum of 250 hot dogs. Now for the range, that would be the Y coordinate that happens when H is happening. So if H is 0, if he sells 0 hot dogs, he still needs to pay a minimum of $120 and up to a maximum of $370, and that's how much it will cost if he sells 250 hot dogs, because 250 hot dogs, $1 each, plus $120. The revenue, the domain will be the same. He can still only sell between 0 and 250 hot dogs. And the range is going to be from 0 up to 625. And again, that's just plugging in 250 into the revenue equation. The profit, the domain for the profit is going to be between 0 and 250 because that's how many hot dogs he can sell. And the range for the profit is going to be between negative 120 and positive 255. Just plugging in those numbers into this equation up here, the domain numbers. And then part F, what is the maximum daily profit the vendor can earn? We just figured that out right here. So max daily profit equals $255. And that is just by checking if he sells his maximum number of hot dogs, which is 250, and putting that into this equation, this profit equation, we would get $255 out. All right, so I hope that helps and that you're able to understand that. Let me know if you have any questions, and have a great day.